Hello, this is Mike at Gamefromscratch, and welcome back to our ongoing Haxe and Heaps tutorial series. This is part 2. Today we're going to start looking at the basics of 2D graphics. And now with all these tutorial series, I assume you've gone through the previous part. So I'm not going to go through our basic application framework or how to set up the IDE or any of those things. I assume you have already gone through part 1. So if I do something, it doesn't make sense to you, and you haven't done part 1, it's probably because it's in part 1. Alright, so back to part 2. So today, like I said, we're talking about basic graphics. This is things like drawing on screen. And really, that's about it. It's going to be a very focused tutorial, but there's a lot of very important concepts to cover here. So let's jump right in. Now, here is Haxe Develop. I've already pre-configured it for our code to start working. So this is a basic project. I set up the heaps dependency and the resource director. I also copied an image file into said directory. So it's called logo.png. You're going to need some kind of a graphic to follow along. There's no real requirements on this one. It doesn't have to be power of 2. It doesn't have to be any particular size, etc. Now that is something you should probably be aware of though, especially on a lot of mobile devices. Generally, you will find a power of 2 texture. That is 256 by 256, 256 by 512, 1024 by 512, 2048 by 4096, etc. Any of the powers of 2 tend to perform better, and on older versions of OpenGL it was a requirement. So even though you don't need to be powers of 2, often it's just a good idea to keep your textures at that size. If you've got no other reason to go one way or the other, just go ahead and make it a power of 2 in size, but there's no requirement for that today. So you notice I've copied it into the res folder. Your typical image files are supported. GIF, JPEG, PNG. Those will all work on all platforms. So those are the baseline 3 sets of file formats to work from. And this is going to work just like we did earlier when we used our font. So it's accessible via the resource. But first, of course, we have to fire that off. So first we do resource.init embedded. So that just loads them basically, or loads the loaders at least. Now we're going to go ahead and get a copy of our logo. And again, we just get it from res. So now that it's there, we can do res, and then it's available via logo, like so. And then this one's not going to make a lot of sense at first, but don't worry, I'll come back and explain exactly what this means later on. But what we want to do is take that resource and make it a tile. I will explain what a tile is shortly. So just go with it for now. So now we have our image. Now we're going to go ahead and create a bitmap. And what we do is we pass in the logo, so this is the graphic we're actually going to use for the bitmap, and S2D, which, if you recall earlier, is our scene, our made for us by the Heaps library scene structure. So basically all we've done here is saying a bitmap is basically an image in memory. The terminology that Heaps uses varies a lot from other game engines. So if you're used to a traditional game engine, bitmap here is generally what we would call a sprite. And unfortunately, Heaps called sprite something else. So really, what a bitmap is an image file or texture that is in the GPU's memory. So it's on your video card, not in system memory, a very important distinction, and we'll show you why in a little bit. So this basically just creates an image that we can go ahead and draw. So now that we've got that, we're done. Actually, that's our example. I'm gonna go ahead and run this now. All right, let's bring you back on screen. As you will see, I made a classic mistake. Here, we need to have a canvas for us to draw on. 1 second. So this is one of those things I covered in the past tutorial, and I forget to do it pretty much every new project I create. Inside of the, in this particular case, because we're creating a JavaScript project in Haxe, if you were doing a Flash project, you wouldn't need to do this. But in a JavaScript project, you need to give it a canvas container for it to actually go ahead and run with. So just go ahead and add one inside here called WebGL. I make it the full width, full height. So now that this canvas exists, our code should run just fine. Go ahead and save that, flip back, and da-da-da. Well, that didn't work. Let's reload. There we go. Okay, there's another thing I'm finding with Haxe, or at least Haxe Develop, is a lot of times for the JavaScript deploy, my initial one keeps a cached copy, so I've got to do a reload after deployment, which is kind of annoying. I'm not sure exactly why it's doing that. I have developer cache turning off, but c'est la vie. So if sometimes you do a deploy and it doesn't work right away, just refresh your browser and you should be good to go. But as you can see here, our image is drawn at the very top left corner. Now if you're wondering about this white border, that's just because of the default HTML padding. I should have turned all the padding and margins, etc. off, and we could have gone right to the edge. But that's why you're seeing this white here. So this here is S2D. This is the canvas that we're drawing in, this big black area. That's owned by S2D. That's the canvas we set up in the HTML file. And this is the image we just went ahead and created. So really, that's all that's involved. Init the resources so that these are available. Create one calling res dot, and then your file name dot .tutile. And then use that to create a bitmap. Once you create this bitmap, it is automatically added to S2D. Now there's another way we can go about doing that. And I'll go ahead and show that right now. This will explain a little bit about what a bitmap being in GPU as opposed to system memory means. There's another way we can go about creating all this. So I'll just reuse the same example. So we're going to go ahead with logo again. And here we're going to go res dot logo dot to, and then this is a very confusingly named function. Part of why I'm going about showing this way. To bitmap doesn't create a bitmap. This is why I wish bitmap was named sprite. It would make a lot more sense. But with bitmap being called what it is, to bitmap isn't actually creating a bitmap. What it is creating is a bitmap data class. So what logo is going to hold here? So actually we should name this something different. Bitmap data. So this is actually just going to hold the bits and bytes that actually go together and are the pieces of our data. Basically, it's a gigantic array or vector of integer values for each color of each pixel within the actual image data. And this is in system memory, not in GPU memory. Now, there's an important distinction there. System memory is slow. GPU memory is fast. System memory, however, can be updated. Updating in the GPU, not so much. So you can create images on the fly this way. If I wanted to, I could go by and multiply every pixel value in there. So if I show you, like right here, I can go logo bitmap data dot. You see, I can do get pixel or get pixels, where I can actually grab the pixel value at a certain x and y coordinate and actually set its value. So that is why you would use bitmap data. If you wanted to actually programmatically access it or make things happen, that's what that's there for. But now we've got this guy in memory. What are we going to do with it? Well, next we got to go ahead and actually create a bitmap out of it. You can't draw bitmap data. You need to create a sprite-derived class. I'll come back and explain that in a minute. But bitmap is a sprite-derived class. So we need to go ahead and create something that can be drawn on our stage. So we're just going to go var bitmap equals bitmap dot create, and we pass in our data. And that's it. Coincidentally, and I should have said this right up front, all of this code is available on Gamefromscratch. I will link it down below. There's a text-based version of this tutorial, so if you need a reference or whatever, you can go there. So if you're worried about me deleting this code or not keeping up, don't worry. All the code's on Gamefromscratch. Okay, so we just created that bitmap. Now the difference here is the first time we created a bitmap using its constructor, and as the second parameter we passed in its parent. So that's where we parented this image to the stage, which is what caused it to actually be drawn on stage. Now what's really cool here is you can actually parent any sprite to any other sprite. So you can create a hierarchy of them. So if the top one moves, all of its children will move as well. So the stage is really just a special sprite that's at the very, very top. But in this case, we don't have the constructor ability to actually say, this is where I want this stage to be added. So now we need to do it the other way around. And that's by calling s2d add child, like so. And we just pass in our bitmap. Now you're noticing the parameter here is a sprite. We will get back to that in a moment, don't worry. So really we just pass in our newly created bitmap to the stage, and at this point we are functionally equivalent code. I'll quit drawing on that screen. All right, let's bring it back. There you go. Not exceedingly exciting, but it is functional. So now that we've actually got this bitmap, let's do a couple things with it. First off, let's position it. So this is easy enough. Bitmap.x equals s2d.width div2. So basically all we're saying there is draw it at the middle of the screen. So bitmap.y equals s2d.height div2, like so. And now we go ahead and run this, and this will draw it centered, sort of. You'll see what I mean. There we go. So we are now drawing centered, sort of. And there's a couple of very important lessons here. When you give a coordinate inside of heaps, it's relative by default to the top left-hand corner. And then it's relative to its own top left-hand corner as well. So if I said, for example, let's do this at 100, like so. Oops, I don't know what that button does. Wish I hadn't pressed that button. Okay. Let that run. Here's our code. And see, now you see it's only drawing 100 over. So when the origin, or the pivot point, we generally call the origin when drawing, especially at a top level window, the origin of your drawing coordinates, so 0 and 0, is right here. Whereas 100% and 100%, or your width and height, is right here. So when you're saying halfway, obviously, it's right here. So that's where your x and y values come in. X is left and right. Y is from top to bottom. In this particular case, some game images you'll see that's reversed, where y will be from the bottom to the top. But in this particular case, in heaps, it is top left corner is the origin, and it goes up from there, which is confusing to say it, but to say this would say be 0y, this would be 100y, 200y, 300y, 400y, 500y, etc., depending on how many pixels are actually in your screen. So there's how the default drawing works. Now sometimes though you're going to actually want to draw, like in this particular case, we wanted this to be in the middle of the screen. And it wasn't. It was in the middle of the screen. Yeah, let me get rid of some of these. It was in the middle of the screen for the top left-hand corner. Now, sometimes you're going to want to draw sprites relative to their midpoint instead of their top left. So let's look at how you can do that now. And what this is done with is, often it's called a pivot in other game images. In this case, it's called dx and dy, standing for delta x and delta y. And those are just simply two values that we're going to subtract every single time from our particular image. So in this particular case, I don't know if this will actually give me information. I think it's a 100 by 100 image. I'm not 100% certain, but we're actually going to get the dimensions of the image as well. So now we're going to go bitmap. Now, remember earlier we did to tile? Well, tile's coming back again. I'll explain it at this point now. So this bitmap actually already has a tile. And the tile can be thought of as a rectangle defining the dimensions of said image. So you often will have one image. Say you had an image that was 512 by 512. Then you had a rectangle that was at 0, 0, 512 wide, 512 high. You basically got a rectangle or a tile that represents the entire image. But it's possible to use a subsection of that. And that's where tile comes in. Basically, tile is maps the percentage of the image itself to use when drawing said sprite. And this is very useful when you've got multiple images, multiple frames of animation or multiple sprites on one sprite sheet. So that's where tile comes in. So you notice we didn't actually create one, but when we created a bitmap, it automatically created a tile at full dimensions for us. And when we created our resource using toTile, it created a bitmap and the tile for us that, again, used the entire dimensions. So our tile is there. Our tile represents the size of the underlying image. And so we can use that to actually determine, first off, where it's drawn relative. So there's the delta x. This is the amount to take away from x to move the pivot point. So we're just going to take away equals minus, and we just want to take away half of its height. So in order to figure this out, is math dot, because we don't want a floating point value, math dot round. So we're rounding down the result of bitmap dot tile dot width. So really simple math, half of the width rounded down, just in case it happens to be, I don't know, 321 pixels wide or something, which would give us a 0.5. dx is an integer value. This could potentially give us a float value, so thus the math round down. And now we're going to do the same thing for the vertical. So dy equals minus math.round bitmap.tile.height div2, like so. And now when we go ahead and draw this guy, ta-da! Centered to the middle of the screen. So that's what we want. That's what we did. So the dx and dy are telling us that instead of drawing relative to here, draw it relative to half of its width and half of its height. And this is very, very handy for when you want to rotate, because you very rarely want to rotate this way. You always want to rotate about the center, and that's where dx and dy come in very handy. And also a little bit more of an explanation of what this tile thing is about. A tile is really just coordinates within an image, or a texture. It's basically saying use this portion of the texture. Now I'm going to use a little bit more of an example that might make this make a bit more sense. So instead of using the whole thing, let's now change this so that bitmap.tile.set size and we'll go half. Like so. So instead of using the full thing, we're actually now only going to use half of the height and half of the width. Oh. All right, remember what I was telling you earlier about the whole could be a float? Yeah, that's why. Go ahead and run that. Not enough arguments. Oh, duh. All right. So that set the width. Probably want to set the height too. Here, so we're telling that source rectangle that's going to determine how much of the image to draw or how much of the texture to draw. Jesus, would you quit picking monitors? See, and there is the end result. So we're only using a small rectangle. We're using a quarter of it now because we've used half of the width and half of the total height. And now we can move this around if we really wanted to. So we could, sample a different spot within this image, etc. So there is where the tile comes in. Tile may not immediately make sense, but especially when we get onto animation, it will make a lot more sense. But in most cases, you're not going to have to deal with it too much, especially if you have one image. Just keep the tile as default and it matches up perfectly. Now, it does make sense to come back and do a little bit of explanation about a couple of the things going on behind the scenes here. First off, let's explain exactly what's going on with S2D. Now, S2D is this magical class that's being created for us. This guy right here. Well, what is S2D? S2D is very close to STD. Let me just bring up the code. I think it's here. So here's the text version of this, by the way, if you want to get into that. Here is the actual source code for Heaps on GitHub. And you will find that S2D is actually a scene. So it's an implementation of a scene. And this is a very handy way of trying to understand exactly how Heaps works. So it implements scene. And scene does a bunch of things. So basically it hooks up back to the underlying hardware behind the scenes. It implements stuff so that we can actually do things like get events, which is very handy. It also ties into something called the stage, which is where these events come from. So this way you can handle things like mouse clicks, input, keyboard input, etc. But you'll notice it implements something called layers. Okay, so our scene, or S2D, is an instance of scene that is created for us automatically. You could create your own potentially if you wished, but you'll notice it is made out of layers. Now, layers is itself a sprite. We'll get back to sprite in a second, but that's an important thing to understand. And really, all layers really allows you to do is layer in other sprites. So when we talk about sprite, a sprite is a thing in the world with position. Now, this is where Heaps kind of varied from the rest of the game world. Generally, sprite means a graphic with a position. So, like a moving graphic. And it goes way back to, in the early 70s, the days of like the Atari 2600 being created. Texas Instruments basically created something called a sprite chip. And so they coined the term. And it used to be back with 8-bit and 16-bit machines. It was all about how many sprites you could push. So there used to be dedicated hardware on the machines for moving sprites. So you had two kinds of things. You had background or static images, and you had sprites, which were things that moved. Things like the player, the ball, the score, etc. Those would be sprites, and they would be handled in hardware. So that's where all this terminology comes from. So Heaps is kind of screwed up a little bit, in my humble opinion here, by using sprite the way they have. If you've come from another game engine, sprite kind of is filling the same role as traditionally node or entity, or generally it's just the position. So when you get into the sprite, mostly the sprite is all about where it is, how it's rotated, is it scaled, that kind of stuff, but it's got nothing to do with drawing. So we're going to come back here for 1 second and we'll look at the class that's all about drawing, and that is drawable. Now you'll notice drawable extends sprite. So your stage, or your layer or scene, you can add children to it like we did earlier, like we did in our code right here. And these children are sprite derived. Now, if you want to actually draw something on screen, however, it's going to be inherited from drawable, like bitmap is. We go back here for one more second, you'll see bitmap is a drawable. Graphics, which is used for like drawing graphics if you wish, is a, where are you, graphics? Here we go. It is a drawable. Text, which we used in our very first example, is a drawable. And finally, is it tile group? I might be making that up. No, making that up. It's animation. Anim is a drawable. So these are inherited classes, and these are basically the building blocks of 2D. So you have your layer at the core. You can add sprites to it. You can add sprites to other sprites. Sprites can be completely empty. If we go back to sprite again, it doesn't draw anything on screen. It's the drawable, which inherits from sprite, which is what makes things actually renderable. And then the only other thing that was kind of in that whole equation that was a little confusing again is tile. And tile, you'll notice, is just base level class. It doesn't inherit from anything. And really, it's just about being a rectangle. So this is just coordinates inside of the texture of your drawable derived class. And that's it. And really, that's about all I want to cover today. So a quick recap, again, back to the top. Your drawing is done. Your origin of your game world is the top left corner, meaning 0 and 0 is the top left corner, while width and height is the bottom right corner. You can change the pivot of an object by changing its dx and dy value of its attached tile. The tile itself is the coordinates of the entity within the object itself it's drawing. I think every single one of drawable classes implements tile in some way, shape, or form. We've got, again, sprites are the position on screen. Sprites can do a couple of other things. We'll see. So we've got sprites have the ability to get bounds, get size, get bounding rectangle, local coordinate changing. You can, again, you can parrot sprites to other sprites. So you can have an empty node and a bunch of other children sprites attached to it. Or you can have, for example, a character. If you wanted to really build it dynamically, you could have hips with a left and right leg and a torso attached, and have the torso with the arm attached, etc. And they will all inherit the movement of their parent by default. So that really is the hierarchy there. This is the classes you should be aware of. And that's about it. That's enough to cover today. That's 23 minutes of pretty good basics of what 2D is about. As you saw, it's actually pretty straightforward. It's nothing really too complicated. You're just going to run into a couple of snags if you're coming from another game engine, because a couple of their terminology, their bitmap, their 2-bitmap, the bitmap data, and sprite, they're quite a bit different than a lot of other game engines' terminology, which will lead you to some confusion. So hopefully I've cleared that all up today. And if you're brand new to this stuff, just keep in mind when you go to a different game engine, the terminology is going to be slightly different. So I hope that all made sense. If there's something that I explained poorly, please let me know, and I will get it down below in the comments, or I will follow it up with another tutorial. Otherwise, we're going to move on to the next part very, very soon, so stay tuned for that. If you enjoyed this, please click like. If you enjoyed it a lot, I do all kinds of content just like this one. I do tutorials, reviews, etc. So click that subscribe button. Hopefully there will be a bunch of interesting stuff coming down the pipeline for you. All right, see you later.